Hello students, this is a video on the QA tests, topic tests available on Bodhee Prep. The idea of these tests is that once you complete the basic concept of a topic and you want to see whether you're able to apply those concepts in a exam or not, you take these tests. Once you've taken a test, with every test there is a video. So you refer to the video after that, you get the solutions and a brief analysis of how you should have gone about the test in the exam mode. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So feel free to download the app and make the most of these tests. This video is on the topic integral solutions and inequalities, and this is test number 3 on the topics. Overall, the test was of moderate level of difficulty, and about 6 to 7 questions net correct would give you a 95 plus percentile. The attempt time for these tests would be somewhere around the 20 to 22 minute mark to go through all the questions and make sure we get our 6 to 7 questions correct. If you look at the question, the first question says, number of solutions of the equation mod of x into 6x square plus 1 is equal to 5x square. Clearly, there are two cases. One, when x is greater than or equal to 0, in which case the mod will open as positive. So x into 6x square plus 1 is equal to 5x square. Now here we get solution number 1, which means x is equal to 0. If x is equal to 0, the two sides will be equal. If x is not equal to 0, then we can cancel out. And we get 6x square plus 1 is equal to 5x. X and x cancelled on each side. This further becomes 6x square minus 5x plus 1 is equal to 0, which means product of 6, sum of 5. 6x square minus 3x minus 2x plus 1 is equal to 0. So 3x into x minus 1, 3x into 2x minus 1 minus 1 into 2x minus 1 is equal to 0, which means 3x minus 1 into 2x minus 1 is equal to 0. So either 3x minus 1 is 0, which gives us x is equal to 1 by 3, or 2x minus 1 is equal to 0, which gives us x as 1 by 2. So this is solution 2, this is solution 3. There is no limit on or no restriction on whether it is a integer or a positive or negative. Therefore, all of these numbers are counted. Second case, x is less than 0, in which case the mod opens as negative. 6x square plus 1 is equal to 5x square. Again, here we've already counted x to be 0, so we cancel out x, and we get 6x square plus 1 is equal to minus 5x, multiplying by minus 1 and cancelling out x. 6x square plus 5x plus 1 is equal to 0, which means 6x square plus 3x plus 2x plus 1 is equal to 0, which means 3x into 2x plus 1. We'll straight forward get opposite sign roots. That is the only change that will happen. This gives us either 3x plus 1 is 0, so x is equal to minus 1 by 3, or 2x plus 1 is 0, which gives us x is equal to minus 1 by 2. This is solution 4, this is solution 5. So how many solutions are possible for x? 5 solutions are possible. I'd say moderate level of difficulty question should take about 2 minutes, but there is a very high chance of missing out x is equal to 0 as a solution here. This question is a question which could give us a negative mark. Consider a triangle drawn on the xy plane with its 3 vertices 41, 0, 0, 41, 0, 0 each. So this is the y-axis, the x-axis, and the line. The line is such that this point here is 0, 41 y-axis. This point here is 41, 0. And the third point is 0, 0. So my triangle here is, say, this point being ABC. So ABC is the triangle that we have. Each vertex being within the xy coordinate. The number of points with integer coordinates inside the triangle, excluding all the points on the boundary. So when y is, we obviously will not count any points here. The first set of points will start from the point where y is equal to 1. Now x could be 1, so we'll have 1, 1, 1, 2, and so on. And this will go up till a point where the point is not on this line. Now on this line, if I look at it, the sum of numbers have to be 41. 0, 41, 41, 0. And therefore the points on this line will be x40. 40, 1, 39, 2, 38, 3, and so on. So when y is 1, the value that x can take is anything less than 40. So x could be anything from 1 to 39. None of the points will lie on the boundary. When y is 2, x could be anything from y is 2, 1 to 38, just less than 40. 38 plus 2, less than 41. 38 plus 2 is 40. When y is 3, x could be anything from 1 to 37. 37 plus 3 is 40 and so on. So 39 solutions here, 38 solutions here, 37 solutions next, and so on. We'll reach a point where y is equal to 39. Here x is equal to 1. So there will be only one solution. 39 plus 1 is 40. When y is 40, the next point with integral coordinates will be on the line itself, which will be 1 comma 40. We will not count it. So the number of solutions will be 1 plus 2 plus 3 plus 4 plus 5 up till 39. The sum of numbers till 39 is nothing but n into n plus 1 by 2. So 39 into 40 upon 2, which is n into n plus 1 by 2, which will be 20 into 39 or 780 points inside the triangle. I think this is an easy question because, again, while practicing, you would have come across questions like these. And it's a straightforward sort of a process, especially when the line is a straight line and not a curve. About a minute and a half to solve problem. How many positive integer values of x is mod of x minus 1 minus 2 mod minus 3 mod minus 4 mod less than 5? Now, if we start opening mods from the outside here, we'll get multiple cases. 2 cases for the first mod. For each of the mod, then we'll get 2 more cases, so 4 cases. Then again 2 more cases for each of them, so 8 cases, and then we'll have 16 cases happening. Obviously, that is not worth it. Also, we are looking at positive integer values. So let us look at the maximum value that can happen. Suppose x is maximum positive, and we want this to be less than 5. Now, the sum of 4, 3, 2, 1 is 10. And less than 5 means an integral value will be 4. So if I start with x is equal to 14, you will see 14 minus 1 will give us 13. 13 minus 2 will give us 11. 11 minus 3 will give us 8. And 8 minus 4 will give us 4, which is less than 5. So the maximum value x can have is 14. As we start decreasing the value from 13, 12, 11 till 11, nothing will change. When x is 10, 10 minus 1 is 9. Positive 9 minus 2 is 7. 7 minus 3 is 4. 4 minus 4 is 0. So we easily go up to 10, not a problem. What happens at 9? 9 minus 1 again is 8. 8 minus 2 will give us 6. 6 minus 3 will be 3. 3 minus 4 will be 1. I'm taking positive values because there are mods, which is less than 5. So even 9 is not a problem. And we start going down. If you put x is equal to 1, for example, 1 minus 1, 0. 0 minus 2 is 2. 2 minus 3 is minus 1, 1. 1 minus 4 is again 3. So even if we go down till 1, nothing really changes. Every time we take a mod, we will get a value that will be less than 5. We can check for intermediate values as well. For example, if we take x as 5, 5 minus 1 is 4, 4 minus 2 is 2, 2 minus 3 is 1, 1 minus 4 will give us 3, which is less than 5. So all of these numbers will satisfy this inequality. So here, rather than making cases, I'm putting values and solving from the extreme positive case of x. We are looking at only positive values. Whatever change happens or whatever values that are excluded will happen when x is negative. That is not something we are looking at. So anything from 1 to 14 will work for x. I will call this a difficult question because the instinct is to make cases. And once you start making cases, you realize it becomes very, very complicated. And therefore, a better approach is just put values from the extreme value. Even if we check for, say, 7 to 8 values, it will not take more than 2.5 to 3 minutes. But otherwise, in terms of concept, a difficult question. There are 100 questions in a question paper. Each correct attempt fetches 1 mark. Each wrong attempt attracts a penalty of 1/3 of a mark. How many different integral scores are possible for a student who attempted exactly 80 questions in the paper? Now, if W questions were wrong, correct answers will be 80 minus W. So the score will be 80 minus W plus 1/3 of W. This has to be integral. Since this is an integer, this will be negative. This has to be an integer as well. And therefore w has to be divisible by 3. The minimum value that the w can take is 0. The next value w can take is 3. Then 6, then 9, and this can go up. The maximum value w will be less than 80 and a multiple of 3, which is 78. So it starts from 3 into 0, goes up to 3 into 26. So the number of values w can take is 27. And for each of these values, there will be a different score. For example, when w is 0, the score will be 80. When w is 3, the score will be 77 minus 1 by 3 into 3, which is 76. When w is 6, the score will be 72 and so on. 27 values are possible. I think easy question, not more than a minute and a half to solve. We're just looking at multiples of 3. The number of integral solutions for the inequality x minus 1, mod of x minus 1 minus 4 into mod of x plus 2 minus 5 less than 0. The critical points here are x minus 1, 0, so x is equal to 1. X plus 2, 0, so x is equal to minus 2. So we are making 3 cases. X is less than minus 2. Minus 2 is less than equal to x is less than 1. And x is greater than equal to 1. In the first case, both the mods will be negative. Therefore, minus x plus 1 minus 4 into minus x minus 2 minus 5 is less than 0 is what we are checking for. This becomes minus x minus 3 into minus x minus 7 is less than 0. Negative, negative, minus will multiply. So x plus 3 into x plus 7 is less than 0. The critical points are minus 3 and minus 7. Positive, negative, positive. How many integral solutions? So x can take values of minus 7 and minus 3. X can take values of minus 6, minus 5, minus 4. All of these lie in the range x is less than minus 2. If we have the next range, x lying between minus 2 and 1, the first one will be negative minus x plus 1 minus 4 into the second will be positive mod x plus 2 minus 5 is less than 0. So minus x minus 3 into x minus 3 is less than 0. Taking the negative sign outside, x plus 3 into x minus 3. Since we are multiplying with the negative, so the inequality sign reverses. The critical points will be 3 and minus 3. Positive, negative, positive. We are looking at the range minus 2 to 1. In this range, we can see the thing is negative, so no solutions in this range. When x is greater than 1, we will have both the mods as positive. So x minus 1 minus 4 into x plus 2 minus 5 is less than 0. X minus 5 into x minus 3 is less than 0. Critical points will be 3 and 5. Positive, negative, positive. Between 3 and 5, the solution is 4. Hence, 4 values of this inequality are possible. Again, cases are to be made and solved, therefore moderate level of difficulty because the process is known. The attempt time might go up to 2 to 2.5 minutes. A and B are non-zero integers. How many ordered pairs A and B exist such that a cube plus b cube whole square is equal to a square plus b square whole cube? Now, if we expand the square here, we'll get a cube square plus b cube square plus 2 into a cube b cube. If we expand the cube, we'll get x plus y whole cube is x cube plus y cube plus 3x square y, b square plus 3xy square. A cube plus b cube is 3ab into a plus b. And this can be written as a raised to power 6 plus b raised to power 6 plus 2a cube b cube is equal to a raised to power 6 plus b raised to power 6 plus 3a raised to power 4 b square plus 3a square b4. a6, 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 a6 cancel. Therefore, 3a 4b square, this is cube. plus 3a square b4 minus 2a cube b cube is equal to 0. Taking a square b square common, we get a 3a square plus 3b square minus 2ab as 0. Clearly, we are looking at non-zero integers, so a square b square cannot be 0. Therefore, 3a square plus 3b square minus 2ab should be equal to 0. Now, if we write this, if we divide the entire thing by ab, we'll get 3 by b, 3a by b plus 3b by a minus 2 is equal to 0. Let a by b is equal to x. So 3x plus 3 by x minus 2 is equal to 0, which means 3x square minus 2x plus 3 is equal to 0. Now if we look at the discriminant for this, we'll get b square minus 4ac. The discriminant is less than 0 and therefore x does not have any real roots. And therefore no integral value for 3a square plus 3b square minus 2ab is 0. Hence the number of solutions, ordered pair that exist for this will be 0. I'll call it a moderate to difficult question, easily 2.5 to 3 minutes to solve, because figuring out the expression will take time. The function gx is equal to x minus 4 plus 4.5 minus x plus 4.8 minus 5, where x is real, attains its minimum. Let us just look at the critical point, because that is where the slope of the line changes. At x is equal to 4, gx will be 4 minus 4 is 0, 4.5 minus 0 plus 0.5 plus 0.8, which comes out to 1.3. At x is equal to 4.5, gx will be 4.5 minus 4, 0.5 plus 0 plus 0.3, which is 0.8. At x is equal to 4.8, gx will be 0.8, 4.8 plus 0.3 plus 0, which is 1.1. Again, there is no need to check, but if we look at the option as well, gx would be 4.4 minus 4, which is 0.4, plus 0.1 plus 0.4, which is 0.9. Clearly, this is the minimum value. Hence, at x is equal to 4.5, the minimum happens. This is the standard process and can be used almost without any exception. Therefore, I'm saying easy question. In about 90 odd seconds, we should get the answer. If we have to solve for this question, we will make cases. There are 3 points where the sign will change. One is x less than 4, x lying between 4 and 4.5, and then 4.5 and 4.8, and then x greater than 4.8. These are the 4 regions where the signs will be different. Less than 4, this would be negative. Less than 4, this would be positive. This would be positive. And therefore, minus x plus 4, minus x plus 4, plus 4.5 minus x plus 4.8 minus x. This will be minus 3x plus 4, 4.5, 4.8, 13.3. So if we look at the graph, it is a decreasing graph. At x is equal to 4. At x is equal to 3, the value will be 4.3. At x is equal to 4, it will be 1.3. So if this is 3, this is 4, the graph is decreasing till this point and will attain a value of 1.3 at x is equal to 4. Between 4 and 4.5, this also becomes positive. So x minus 4 plus 4.5 minus x plus 4.8 minus x. So this is x and minus x will get cancelled. Minus x plus 4 and 4 cancelled. 4 plus 5.3. So at x is equal to 4, it will be 1.3. At x is equal to 4.5, if we put 4.5 here, we'll get the value as 0.8. So till 4.5, it will decrease at a flatter rate. We'll reach 4.8 at this point. Between 4.5 and 4.8, this is positive, this will become negative because 4.5 minus 4.6 is a negative value. So x minus 4 minus 4.5 plus x negative plus 4.8 minus x. This will give us x and minus x cancelled. So x minus 4.8. 4.8 minus 4.7. So 3.8.5, 3.7. So if we put x as 4.5, we'll get 0.8. Until 4.8, the value will increase and go up to 1.1. So as you can see, the value is increasing. And from here, it is evident that the sign of the x's. So here, this will be positive, negative, negative. So we will get x minus 4 plus minus 4.5 plus x minus 4.8 plus x. So we'll get 3x minus 12, 13.3. So from here, the value will keep on increasing. Clearly, the minimum point happens at the central value, which is 4.5, which could have been checked by simply putting in the critical points. So if I have to get the answer, it is an easy question. Solving might take some time. 3x and x and y are natural numbers. Find the number of ordered pairs xy which satisfy the equation 3x minus 7y is 20 and the inequality x plus y is less than equal to 30. Now, if we look at the first or the smallest value of x and y are natural numbers which are positive and satisfy 3x minus 7y is equal to 20. Now, if we start adding multiples of 20 to 7, multiples of 7 to 20 and see whether they're divisible by 3 or not, 27 is divisible by 3. So 9 threes are 27 and 7 ones are 7. Will give us 20. So this one of the ordered pairs is 9 and 1. And here x plus y is 10. Anything less than this would not be natural, would not be a natural number. For example, if we put x as 2, 9 minus 7, y will have to be minus 2. 3 twos are 6, minus 7 minus 2, 14, 20. But this will not be a natural number. The next solution will be add 7 here. So 16 and add 3 here. 60, add 4. So this will become 4. Here the sum is 20. The next number solution will be add 7 here, 23, and add 3 here, 7. This sum will be 30. Anything beyond this will cross 30, and therefore the number of solutions possible for ordered pair x5 where 3x minus 7y is 20, such that x plus y is less than equal to 30 will be 9, 1, 16, 4, 23, 7. 3 solutions are possible. The process is standard, but since there are two constraints, I'm saying moderate level, should not take more than 2 minutes to solve because the numbers are very small. How many positive integer solutions xyz exist for the equation x plus y plus z is equal to 10? So that no two of the three quantities are equal. No two equal. So all of them have to be different because all three cannot be equal. No two, all of the values have to be different for x plus y plus z is equal to 10. X, Y, Z. If we put x as 1, y can be 2, 3, sorry, 2, 7, 3, 6, 4, 5, 5, 4, 6, 3, 7, 2. We have 1, 2, 3, 4, 5, 6 solutions. If x is 2, y and z are 8, so can be 3, or rather 1, 7, 3, 5, 4, 4 is not possible, 5, 3, 7, 1, positive integral. if x is 3, y and z are 7. So 1, 6, 2, 5, 3, 4 is not possible, 4, 3 is not possible, 5, 2, 6, 1. If x is 4, we had 1, 2, 3, 4, 5, 6 solutions here. 1, 2, 3, 4 solutions. 1, 2, 3, 4 solutions. If x is 4, y plus z is 6. 1, 5, 2, 4 is not possible. 5, 1. If x is 5, we will have x is 1, 4, 2, 3, 2, 3, 3, 2, 1, 4. X is 6, 4, 6, 1, 5, 2, 4, 3, 3, 4, 2. X is 6, we'll have 4. 1, 3, 2, 2, 3, 1. X is 7, we'll have 3, 1, 2, 2, 1. X is 8, the only possible is 1, 0, 9 and 10 are not possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, 24. 24 solutions are possible in all of these cases. No two equations, no two quantities are equal. Again, this is one of the most rudimentary ways of solving it. Barely, all I did was counted the solutions. Even in this case, the attempt time should not go beyond maybe 2 minutes. If this is not something that we are doing, if this is something that we are doing, it will take about 2 to 2.5 minutes. And that at this point, I call the question moderate. The other way of looking at this question will include a bit of PNC. So what we can do is we can find out the total positive integral solutions for x plus y plus z is equal to 10. Positive integral solutions for x plus y plus z is equal to 10 is given by 10 minus 1 c 3 minus 1. A formula that I'm picking up from permutation combination. This will be 9 into 8 by 2, which is 36 overall. Now, when there will be cases where two values are equal. This consists of all the values. There could be cases where two values are equal. So if x and y are equal, they could be 1, 1, 2, 2, 3, 3, 4, 4. Correspondingly, z will have value. So 4 cases here. Similarly, yz equal could be 1, 1, 2, 2, 3, 3, 4, 4. 4 plus 4, 8. 4 cases here, and x and z equal could be 1, 1, 2, 2, 3, 3, 4, 4. Corresponding z for y. So in these 12 cases, two values are equal. Subtract them from 36, you get 24 cases overall. This is a faster way to solve, but even in the worst case scenario, when we are counting, not more than 2 to 2.5 minutes to solve. X minus 1 into x minus 2 into x minus 3, these are consecutive numbers. Is 6 raised to power 5. How many integer solution exists for the given equation? Now, if one of them is negative, all three are negative, we will not have a positive value. At max, two of the numbers can be negative. If two numbers are negative, minus 2, minus 1, 0. Then the product will be 0, not possible. One of the numbers cannot be negative. So all these numbers have to be positive. Minus 3, minus 2, minus 1 will give us a negative value. Minus 2, minus 1, 0 will be 0. Minus 1, 0, 1 will be 0. And therefore, all the three numbers have to be positive first of all. So we are looking at positive values of x minus 1, x minus 2, and x minus 3. Next, since there are three consecutive numbers, if the numbers are even, odd, even. In this case, we will have a multiple of 2. We will have a multiple of 4, even, odd, even. And then there will be an odd multiple. For example, 2, 3, 4, 4, 5, 7. 4, 5, 6. 6, 7, 8, and so on. 6, 7, 8, 8, 9, 10. 10, 11, 12. As we can see, in every case, if we multiply, here 2 into 3 into 4 will become 4, 3, 12, 24. The powers of 2 and 3 cannot be equal. In this case, we'll have 5, here we'll have 7, here we'll have again a multiple of 5, a multiple of 11. So in almost all other cases, there will be other prime numbers involved, and therefore the product will not be simply a power of 6, because 6 is made up of only 2's and 3's. 6 raised to power y is equal to 2 raised to power y into 3 raised to power y. Even, odd, even. If we are looking at it, there is always another number that gets involved, which is either a multiple of 7 or a multiple of 5. 5, 7, 5, here there is a multiple of 7, here there is a multiple of 11, here there is a multiple of 7, and so on. So there is, see, the first case where we have 2, 3, 4, that is not a power of 6, 4 to the 12 to the 24 is not a power of 6. So 6 raised to power y is not possible. If we look at odd, even, odd, the first case is 1, 2, 3, which is 6 raised to power 1. So this is one solution that we have. Beyond this, when we say 3, 4, 5, again, there is one odd number that is not a multiple of 2 or 3. When we say 5, 6, 7, again, in 3 consecutive numbers, we will have one odd number which will be a multiple of 3, and another odd number which will be a multiple of some other odd number. For example, could be 7, could be 11, could be 13, and so on. Whatever odd number that we have, which is not a multiple of 2 or 3, will ensure that this is not the product is not a power of 6. And therefore, the only solution possible is when x minus 1 is 1, or rather, x minus 3 is 1, x minus 2 is 2, and x minus 2 is 3, and x minus 1, 2, 3 consecutive numbers. In this case, the product will be 6 raised to power y or 6 raised to power 1. So x in these cases is 4. 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. And y will be 1. This is the only solution possible. Hence, option B becomes the answer. I'll call this question a moderate level of difficulty. When hit and trial gives us the answer, looking at the pattern, we'll be able to spot that only one solution is happening. Just start by putting the values as 1, 2, 3 for the smallest number and work from there. About 2.5 minutes to solve at max. Overall, if you look at the level of the analysis of this test, moderate or difficulty about 22 minutes. Again, 22 minutes. I'm getting the answers in the best possible manner, on the most efficient manner that I can. 6 to 7 questions that I am looking for. My questions will be 1, 2, 4, 5, 7, 8, 10. Which are these? Would attempt this question, but it's a tricky question. The solution x equal to 0 is very easy to miss out. Again, I have done this question earlier, this kind of questions earlier, therefore attempting this question. This, I think, is a difficult question in the sense that many mods involved, so not counting this. This, I think, is a straightforward question. When looking at multiples of 3, would have attempted this. This also, the cases were simple, only 3 cases were to be formed, so would have attempted this question as well. This question, I think, is a difficult question, may not be able to solve it every single time, so not counting it. This is a straightforward question, just put the value of x as the middle number and get the answer, so would have attempted it. No need to really even solve such kind of a expression, because you've seen this enough to know that it is a middle value, so attempting this question. This also, the cases were simple, 3 cases were being formed, so would have attempted this question. Here again, unless I know how to solve it using combinations, it might not be possible to make all the cases every single time. So I'm not counting this question. This I would have attempted because the number of cases is very small. And the moment you go from the smallest number being 1 to 7, 1, 2, 3, 4, 5, 6, and you realize only one case is being formed. Therefore, would have attempted this question. So, I mean, might get 6 out of the 7 correct, but 1, 2, 4, 5, 7, 8, 10 would be my attempt.